It's a common misconception that the sky is blue because it reflects the color of the oceans, but it's actually the Earth's atmosphere and a process called scattering that makes the sky blue. The Earth's atmosphere is made up of lots of different air molecules. When sunlight travels through our atmosphere, it often gets redirected off of these air molecules. This is known as scattering. This phenomenon scatters shorter wavelengths more since they are smaller. So colors that travel in shorter wavelengths, like blue, will get scattered more than longer ones, like red and orange, and therefore appear into our eyes more. This is why the sky appears blue throughout the day. Shorter wavelengths get redirected more, causing blue light to reach your eyes far more than the other colors coming from the sun's light. But wait, if you've been paying attention to the visible light spectrum, you'll see that blue isn't the shortest wavelength, it's actually violet. So, if shorter wavelengths are scattered more, why isn't the sky violet? The sky isn't violet because more of the sunlight entering the atmosphere is blue rather than violet, and also because our eyes are more sensitive to detecting blue wavelengths rather than violet wavelengths. Now, as you might have noticed, the sky isn't always blue. Sometimes it's the colors of the longer wavelengths, orange and red. When the sun is low in the sky, during sunrise and sunset, the sunlight has to travel further through the atmosphere to reach our eyes, because, as I explained in further detail in my Why Are Planets Round video, which you should totally check out if you haven't yet, the Earth is wider near the equator. It's actually more like an ellipse, not a perfect sphere. Since the light has to travel further, we don't see the shorter wavelengths because they get scattered away in all directions and can't reach us. However, longer wavelengths can reach us since they don't get scattered as much, turning the sky red and orange at sunrise and sunset. And guess what? There's a time in the day when the sky can be all the colors at once. Well, sort of. At noon, when the sun is directly overhead, the sky can appear white. This is because all the colors' wavelengths get to travel the shortest possible distance through the atmosphere to reach us, getting scattered very little. And all the colors combined make white. All this atmosphere wavelength talk might make you wonder, what would the sky look like in other atmospheres? Well, let's look at Mars. Mars' atmosphere is much, much thinner than Earth's. The lack of air molecules means that scattering happens less, and therefore has a very small effect on the light entering Mars' atmosphere. We might expect Mars to have a faint blue tint in the sky because of this, but due to the amount of dust that is suspended in the air, the daytime sky appears more yellow. This is because the larger dust particles in the air absorb the short wavelengths and scatter the remaining colors, giving a butterscotch tint in the Martian sky. During sunrise and sunset on Mars, however, the sunlight has to travel further, a distance that is similar to Earth's daytime distance, so the blue light gets scattered more, providing a blue glow to the sky around the sun in the hours near dawn and dusk. Now let's look at the moon. The sky from the moon wouldn't even appear to have a color. The atmosphere is so thin that it is basically non-existent. When the atmosphere is this thin, there are basically no molecules there to scatter the sunlight, so whether it is daytime or nighttime, the moon's sky is black. Uranus, Jupiter, Neptune, and Saturn's skies would be blue like Earth, but all slightly different opacities, since some are further away from the sun than others, so there's less light that reaches them. Venus is closer to the sun, so it gets more sunlight, but due to its thick atmosphere, only about 20% of the sunlight reaches the surface, making the sky orange or yellowish. Now on to our final planet, Mercury. Like the moon, Mercury has virtually no atmosphere, giving it a black sky. But it would be very hard to see any stars in the sky since the sun is so bright and so close. Hard times being the closest planet to the sun. Well, I hope that answered your question, Sam, and I hope everyone learned something new. I'll see you later.